Okay, so we need to be able to do a conversion from polar to Cartesian form as well as going the other way around from Cartesian to polar. This one's quite easy. Probably the best way to start is to show you on the Argand diagram. We've got the real, the imaginary. Polar form, don't forget, is r theta, and that's the polar, and Cartesian is x plus iy. So this would be r, and this would be theta. So here is my z in polar form, r units out there, and theta always start 0 going out towards the positive x real axis and going in the anti-clockwise direction. So we want to know how to come up with x plus iy for this complex number. This would be my x value, and this would be my y value. So if we look at this right angle triangle here, we know that the cos of theta, cos of this angle theta, is adjacent over hypotenuse, and the adjacent would be the x over r. So if we multiply both sides by r, we get x equals r cos theta. We also know that r is equal to the mod of z, the length from there to there. So we can say that's equal, instead of r there, we can say mod z cos theta. And we also know that the sine of theta, opposite over hypotenuse, so this is the same as y. So my y value, which is what we're trying to come up with to make it into Cartesian form, y, multiply both sides by r, and we get r sine theta. Once again, we could substitute, instead of r we can say that's mod z sine theta. So that's quite a bit straightforward, and I suppose it's a good idea just to do a little example to show how that works. So if we want to do convert 7 pi on 4 to Cartesian form, one of the first things I think you should do is to try and put that on an Argand diagram, because that sort of minimises the chance that you can make a mistake with signs with the x and y. So 7 pi on 4. Okay, so we've got our Argand diagram. Real, imaginary. We know that that's, if we're looking first of all at theta, it's 7 pi on 4. So this would be 0 degrees, or sorry, 0 radians. This will be pi on 2 radians. This is pi. This is 3 pi on 2, and 0 radians or 2 pi radians. Now this is 7 pi on 4. So it probably would be good to make all these something over 4. So to make that as something over 4, pi on 2 would be 2 pi on 4. Multiply top and bottom by 2. This is pi on 1. So multiply top and bottom by 4 and you get 4 pi on 4. 4 pi on 4 and pi are exactly the same. 3 pi on 2, so we multiply top and bottom, so that's 7 pi on 4. Excuse me, 2 times 3 is 6. I'm thinking of what this is up here. So that's 6 pi on 4, and 2 pi, which is 2 pi on 1, multiply both top and bottom by 4 and you get 8 pi on 4. So 7 pi on 4 is going to be halfway between 6 pi on 4 and 8 pi on 4. So it is going to be out here. And you come out 8 units. So that angle from there all the way around to there is my theta, and that is 7 pi on 4. To get all the way up to here, if you went all the way around one complete revolution, you've gone around 2 pi, which is 8 pi on 4. So you've only have to go another pi on 4 up there. Okay, so from what I've done up above, we know that the x value is equal to r cos theta and the y value is equal to r sin theta. So we know that x is equal to r, which is 8, cos 7 pi on 4. Okay, now we need a little bit of knowledge of the unit circle to work this out. It'll be 8. Now cos of 7 pi on 4, we've got C, A, S, T. Cos is positive, all sine, cos and tan are positive, sine positive, others negative, tan positive. So 7 pi on 4 is in this quadrant. There's 7 pi on 4 all the way around to there. So it is simply cos. It is positive because cos is positive in here. And then 7 pi on 4 is around to there. We just work off the angle off the x-axis, which is just pi on 4. Now, cos pi on 4 is one of our magic triangles. We've got 1, 1, root 2, and this is pi on 4, and that's pi on 4. Pi on 4 in degrees is 45 degrees. So the cos of pi on 4 is 1 on root 2, so it's 8 times. Cos of that is adjacent over hypotenuse, 1 on root 2. It is common not to put a surd on the bottom, so we can multiply top and bottom by root 2 over root 2. And we get 8 root 2, 8 times root 2 over 2. So that's equal to 4 root 2. My y value, imaginary, is 8 sine 7 pi on 4 equals 8. Now we've got to work out the sine of 7 pi on 4. 7 pi on 4 we said is in this quadrant here. And in this quadrant, sine is negative. The sine, and then we work off the angle that has to go from there up to the x-axis. So 7 pi on 4, the angle is pi on 4. Equals 8 times negative sine of pi on 4. Sine is opposite over hypotenuse, 1 on root 2. Multiply top and bottom by root 2 to make sure that our denominator doesn't have a surd. Is negative 8 root 2 by multiplying out across the top. Root 2 times root 2 is 2. 2 into 8 goes 4. Negative 4 root 2. So now we can put it together. So 8 7 pi on 4 is equivalent to x plus iy. My x is equal to 4 root 2. And my y is negative 4, so that'll be minus 4 root 2. So I 4 root 2. So 4 root 2 minus I 4 root 2. They are equivalent complex numbers. So just going over the strategy again. First step, I think always once you've got your complex number in polar form is to do a sketch, and that way you're less likely to make a mistake when you come up with the signs for the x and the y. You know down here that x is going to be positive, and you know that you must get a negative y value because in this quadrant x is positive and y is negative. That's the complex number that you're trying to find in Cartesian form. So you know x has got to be positive, you know y has got to be negative, and if we look at our answers, we've got that. So if you do a good diagram, it also allows you to take some time to work out what's going on with 7 pi on 4. So we just work out what quadrant it's in, and use your knowledge of the unit circle and CAST to work out which one's positive, which one is negative. And so we come up with the answer.